It's myself, Ghanshyam Domse. Today we are going to see the topic recommendation system and singular value decomposition strategy. Recommendation system. The basic concepts are user items and other ratings, which is basically used for implicit type of feedback about the product, like the fact of having bought them. Every model must work with the known data, we can say supervised kind of scenario, which is able to suggest the most suitable items or to predict the rating for all the items which is not evaluated yet. We are going to discuss here two different kinds of strategies, user or content based, and second one is the collaborative filtering. The first approach is based on the information we have about the user or products and its target associate with the new users with the existing group of peers to suggest all the items positively rated by the other members, or to cluster the product according to their features and propose a subset of items similar to one taken into the account. The second approach, which is a little bit more sophisticated, work with the explicit type operating and it purpose to predict this value for every items and every user. Even if collaborative filtering need more computational power nowadays with the great availability of cheap resources and allows using the algorithm with the billions of users and products to provide the most accurate recommendation system in the real time. The model can be retrained or updated every day. Now, Navy user base system. Now, in this scenario, we are assuming that we have the set of users and which is represented by the features vector in the following way. Now we have a set of items capital I is equal to I1, I2 up to the IM. Now let's assume that we want to show the relationship between users and item and which is an explicit action or feedback has been performed by using following way. Now in user based system here we are using k nearest neighborhood approach and we can immediately determine the ball containing all the users who are similar in our sample in the following way. At this point, we can create a set of suggested item by using previously introduced method. Now in the other word, we can say a set of contains all the unique products which is positively rated or bought by the nearest neighborhood. I have used here adjective navy because there are similar adjective here. User based system implementation with the SkyKit code, and let's see the step-by-step SkyKit code. For that purpose, we need a dummy data set of users and product. In the following sample or example, we are considering here 1000 number of users with the 4 number of different products, and each product is associated with the ratings which is bounded by between 0 to 4 or maybe 5. Now let's see the code. First of all, we need to import the header file, import space numpy as np, then nb underscore users is equal to 1000. Then we want to create a product, dummy products. So each users can be associated with the product with the rating. Now let's assume that for the purpose of product, we are going to create association for 20 number of different items. So nb underscore product is equal to 20. Now if you observe in the following association matrix, if the items is there 1 2 3 4 up to the 15 number of items or around 20 number of items, and if you observe the 0, it means that user didn't buy anything. And association matrix where each user is linked with the number of products which is bounded in between 0 to 5 maximum. So kindly observe this association matrix. Now at this point we need to cluster the users by using nearest neighborhood implementation provided by scikit-learn. First of all, we need to import sklearn.neighbors, import nearest neighbors. Then we need to here we are going to select 20 number of neighbors and Euclidean radius which is equal to 2. So the parameter which is used when we want to query about the model to know which item is contained in the ball and whose center is the sample with a fixed number of radius. In our case, we are going to query about the model to get all the neighbors to test the users. Now test users is equal to, if you observe 2032, these are the value related with the test users, and when we print the neighbors we will observe 9333, 67, 901, 208, 23, 720. In this way we need to build recommendation system list by using association matrix. These are the neighbors actually. The neighbor 933 is nearly neighbor which is associated with the 67. 901 is associated with the 208 in this way. Now we want to suggest the products to each number of neighbors. For that purpose, this is the code. Here we are writing. Now for each neighbors, we can retrieve the products he can buy or she can bought and perform the union, avoiding the inclusion of the items with zero and double elements. The result is the list, and which is suggested can be obtained almost in the real time for the many different system. Now if you observe here in the output, it print the suggested products which is recommended to the list of neighbors. Whatever the list of neighbors we have, we want to suggest the list of products to that neighbors. Now next thing is content based system. Now in this system, this is more probably with the simplest method, and it is based only on the products, and which is modeled as feature vectors. I is equal to I1 I2 up to the in, where I of n is belongs to the real values or real vectors. Just like the users, the features can also be categorical, and for example, suppose we have a book or movie, they can be used together and with the numerical values, like movies rated by the number of reviews, and if we consider book which is rated by their price. So with respect to this, after encoding them, then a cluster strategy is adopted even if the most used k nearest neighbors, as allows controlling the size of each neighbors to determine the given sample product and the quality number of suggestions. Now let's see the Scikit learn how to implement this concept of content based system by using Scikit learn library. Suppose we have again 1000 number of users, and we having the dummy data sets of different items. If you observe, we are the four different kind of items. In the previous example we will see the number of users with respect to the product. Here we will see number of items with respect to the users, right? Now in this case we are having 1000 number of samples with the four integer features, which is actually bounded between 0 to 100. In the previous example we are bounded the rating in between 0 to 4 or maybe 5. Here we are bounded the value between 0 to 100. Then we will proceed in the previous example towards the clustering. Now here again we are using nearest neighborhood cluster algorithm. At this point it possible to query our model with the method radius underscore neighbors. Now we are going to see the code in this way, and we will get some different number of products with their different kind of suggestion in the arrow. If you observe the value 844, 340, 657, in this way we will get the list of suggestions with respect to the users. Now when clustering with k nearest neighbors, it is important to consider the metric adopted for to determine the distance between the samples. Basically, we can measure the sample by using Hamming and Jacob distance, and the formal defined as the disagree the proportion between the two vectors, and this is the code related with the Hamming distance, and this is mainly used to measure the distance between two different things by using Hamming distance, and this is the output in the following code. Now this is the formula for Jacob distance, and Jacob distance is particularly useful for to measure the dissimilarity between the two different item sets. Suppose we have A and B, two different items, and we want to measure the dissimilarity between the two item sets. If our feature vector are binary and it's immediate to apply the distance using Boolean logic, Using the previous test values, we will get the output like 0.57. This is the Jacquard distance between the A and B. Now observe this again. What is this? This is the Hamming distance between A and B. If you observe, the Hamming distance is 0.40, and if you observe Jacquard distance, this is about 0.571. Now this measure is bounded between 0 and 1. That is nothing but totally dissimilarity. Now for the Hamming distance, it can be very useful, and it's necessary to compare the atoms where their representation is made up of binary states like yes, no. When we are using category value, that means yes, no, present, absent, like this, we are using Hamming distance approach. And if you want to adapt different matrix for k nearest neighbors, it is possible to specify directly by using metric parameters. So k nearest neighbor algorithm also supports two different kind of thing. We can say a metric. One is the Hamming and second one is the Jacquard. And by using this, you can calculate the distance between the atoms. Now next is second type of approach, collaborative filtering. Now in the collaborative filtering type of approach, let's see the following matrix, and this is the user item based matrix, and which contain the number of rows and column. Now rows represented by the number of users and column is represented by the number of atoms, and you want to see the relationship between users and atom by using collaborative filtering approach. All of you understand right now? Now in this case, the rating are bounded by between 1 and 5. 0 means no rating. If you observe here, the lot of zeros are there, it means no rating, and the rating is bounded in between 1 and 5. Now our goal is to cluster the user according to their rating vector. This allows producing the recommendation even where there are no explicit pieces of information about the users. If the information is not available with the user, at that time you need to use this collaborative filtering approach. However, what is the drawback of this? This is called as cold startup, which means a new user has no rating and it's impossible to find the right neighborhood because he or she can belongs to the virtually to any clusters. This is the drawback. Now in order to build this model, first of all we need to define the user item matrix as a Python dictionary. Now let's see the syntax of Python dictionary. Suppose user 1 is related with the item 1 and which is having some rating. Similarly for item 2 having some ratings in the approach. In this approach we can say this is the Python dictionary approach. Now the missing value in a user internal dictionary means no rating. In our example, suppose we are consider 5 number of users with the 5 number of items. Now let's see the following code. Now in this code, user item matrix contain the 5 number of users and which is related with the item. Suppose one user is related with the item 2, 5 or 3 and second user is related with the items 1, 5, 2. Similarly in this way. Now matrix preference data model. Now by using this we need to calculate the matrix preference data model that measures the distance actually between the user item matrix, and this is defined. We need to pick up the matrix therefore distance function. So this is the code about to find the user similarity model by using the Euclidean distance. So in this way we can calculate the user based recommendation system that suggests the following predictor rating for the items too. Suppose whatever the items you have taken previously for 5 number of items, if you observe 1, 2, 3, 4, 5 items, and for the purpose of calculations of ratings here we are using the approach user similarity model by using Euclidean distance. So when we apply the user based recommendation system, we will get the ratings for each and every item. Suppose here item 2 is rated by 3.6, item 5 is rated by 3, item 3 is rated by 2.5. In this way we will get the different rating by using user based recommendation system. Now model based collaborative filtering. Now in this model based collaborative filtering, this is the currently one of the most advanced approach, and it is the extension of what was already seen in the previous section. The starting point is always rating based user item matrix. This is similar to previous one. However, in the case we assume the presence of latent factor for both user and items. In the other word, we can define the generic user in the following way. The generic item is also represented by in the following way. Now we want to learn something related with the ranking is obtained by in the following way. If you observe this formula, we can say that ranking is obtained from the latent space of rank k, where k is the number of latent variable, and we want to consider in our model. In general, there are the rules to determine the right value for k, and so best approach is to check the different values and test the model with the subset of known ratings. However, there is still a big problem to solve to finding the latent variable is. There are several strategies, but before discussing them, it's important to understand the dimensionality of our problem. Suppose we have the 1000 number of users, 500 number of products, and the matrix M is associated with the 5 lakh of elements. Now, if we decide to have the rank equal to 10, it means that we need to find around 50 lakhs variable constraint by the known rating. As you can imagine, this is the problem can easily become impossible to solve with standard approach, and parallel solution must be employed. Now next topic, we are going to say singular value decomposition. Now what do you mean by singular value decomposition? This is again used for the purpose of rating calculation purpose. In the singular value decomposition, this is the method of decomposing a matrix into three different order matrices. First one is, let's say the equation capital A is equal to U as V raised to T. A is nothing but it is the matrix M by N, U is nothing but it is the orthogonal matrix, and S is nothing but this is the diagonal matrix, where V is an orthogonal matrix. Now the reason why the last matrix is transposed will become clear later on. With this explanation also we have the term orthogonal. For the moment we will assume that suppose M is greater than N, and what happens when this is nothing true, and quite interesting, one of the key in my opinion to understand the singular value decomposition. Now singular value decomposition is represented by using summation notation in this way. Now suppose we have the variable like s is nothing but this is a diagonal matrix s into the vector, and we simplifying the expression into the singular summation, and the variable s of I is called as singular value, and this is normally arranged from the largest to smallest. Okay, so here we are arranging the value of variable s of I, which is a singular value, which is normally arranged from largest to smallest. This is most important thing. Now the columns of U are called as left singular vectors, while the column V are called as right singular vector. Now we know that U and V are these are the orthogonal matrix. This is represented by in the following way. So capital I is nothing but this is the identity matrix. Only the diagonals of the identity matrix are 1, with all other values being 0. This is most important. Now because U is not a square, we cannot say that U is the transpose of U, that is I. So U is the orthogonal in one directions. Using the orthogonality property, we can rearrange into the following pair of equations. So this is the representation of the equations. Now since we are taking the transpose of that particular matrix, and we will finally get the formula A raised to T is equal to VSU into T. This is the matrix in transposed format from which is actually coming from U and V. Now let's say the SkyKit code of this thing, SkyPy. First thing to do with create a dummy user item matrix. This is the dummy user item matrix which is having size 20 comma 10s. Okay, so 20 is represented by the number of rows, and 10 is represented by number of column. 20 is nothing but number of users, 10 is nothing but number of items. So by using SVM we can calculate the singular value decomposition, and here we are printing the value of m by using SVM. So we are assume that here 20 number of users and 10 number of products, and the rating are bounded between 1 and 5. 0 means no ratings. Now we can decompose the SVD by using following way. So for the implementation of SVD we need to require SciPy code implementation, and here we are using SVD function. We got three different kind of thing, a USV. Okay, then we will print that shape of U, S and V. U contain 20 number of users and 20 number of again the products. S contain 10, 10, V contain 10 and 10. Now let's consider only first 8 singular values, and which will have 8 latent factors for the both users and items in the following way. So we use the SciPy SVD implementation, which is actually transposed in the following manner. Now write a code, and finally we will get rating prediction for the user 5 and item 2. So our output is 2.38. So in this way SVD we will see the part of SVD, singular value decomposition strategy, which is actually used for the purpose of rating calculation or rating prediction purpose. So these are the different web references we are using. So thank you so much.